You need to turn speech into text in Python, and Azure gives you 3 different doors to walk through. Pick the wrong one and you fight latency, cost, or throttling for weeks. In this video, we frame the real decision: when to use real-time streaming recognition with the Speech SDK, when to use the fast transcription API, and when batch transcription is actually the right call. We'll cover the criteria that matter, show real Python, and end with a recommendation framework you can apply today. Start with one question: is the audio arriving live, or do you already have a file? If audio streams in from a microphone or a call in progress, you want real-time recognition over the Speech SDK, which holds a WebSocket open and returns partial results as the person speaks. If you have recorded files, you have 2 choices. The fast transcription API gives you a synchronous result in seconds for a single file, ideal for an interactive request. Batch transcription is asynchronous, reads many files from blob storage, and is built for thousands of recordings where you don't need an immediate answer. For criteria, drive the choice. First, latency. Real-time streaming gives you interim hypotheses in a few hundred milliseconds. Batch can take minutes. Second, audio source. Streaming accepts a live microphone or push stream, while batch and fast transcription need a finished file or a blob URL. Third, throughput and cost. Batch is the cheapest per audio hour and handles scale, while streaming bills per connection and is sensitive to concurrent session limits. Fourth, features like diarization, word-level timestamps, and custom models differ across paths, so confirm support in the current Azure docs before you commit. Here's the streaming path with the Azure Cognitive Service speech package. You create a speech config with your key and region, point audio config at the default microphone, and start continuous recognition. The recognizing event fires with partial text as the speaker talks, and the recognized event fires with the finalized phrase once an utterance completes. This is non-blocking and event-driven, so you wire callbacks and let the SDK manage the socket. For production, store the key in Key Vault or use Microsoft Entra ID token authentication instead of a raw key. Even within real time, there's a sub-decision. Single-shot recognition. Recognize under once, captures one utterance and stops at the first silence, which suits a short voice command or a search box. Continuous recognition keeps the session alive for dictation, meetings, or live captioning, and you stop it explicitly. Continuous costs more because the connection stays open, and you must handle session and cancellation events to reconnect cleanly. Rule of thumb: use single shot for short, bounded interactions and continuous only when you genuinely need an open-ended stream. In a real application, the microphone or call audio feeds your Python service, which holds the Speech SDK session to Azure AI Speech. Pull the credential from Key Vault and push finalized transcripts onto event hubs or service bus so downstream consumers like analytics, captioning, or a language model can process them without blocking the recognition loop. Keeping transcription and downstream work decoupled is what stops a slow consumer from stalling your real-time stream. A few traps. Concurrency. Each region has a default cap on simultaneous real-time connections, so check your quota and request increases before launch. Audio format. Streaming wants 16 kHz, 16-bit PCM for best accuracy. Resample early. Network drops will end a session, so handle the cancelled event and reconnect with backoff. And language. Auto language detection and custom speech models add latency and have their own limits. All of these numbers move, so verify quotas and pricing in the current Azure docs. To decide if audio is live, use real-time recognition with the Speech SDK, single shot for short commands and continuous for open streams. If you have one recorded file and need an answer now, use the fast transcription API. If you have many files and can wait, use batch transcription for the best cost at scale. Your one action today: Prototype the continuous recognition snippet against a microphone. Measure your real partial result latency and confirm your region's concurrency quota before you design for production. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.